Hello everyone. Today we'll discuss about timers. Now timers are basically used for generating time delays. So say for example, see I want to generate some time delay or some specific time delay. Now that can be generated with the help of timers. I can also generate the time delays with the help of for loops. But the only difference here is I cannot able to know what is the amount of delay that I want to generate or else that I have generated. But when I'm using timers, I can specify the time delay so that the same amount of time delay can be generated. So that's the advantage of using timers. And apart from delay generation, we can also do many things with timers. So we'll see each of them. Okay. Now let us start with the features of timers which comes under LPC2148. As you can see here, it's a 32-bit timer, and we can use them as counter or else as timer, as similar to the timers which we have used in 8051. Okay, so they can be used as timers or else as counters in the same way. Now these timers can also be used as timers or else as counters, that is delay generation or counting the external events. Okay, apart from those things, now it has some additional features like it is provided with a capture. Okay, it is provided with capture channels, and it is also provided with match channels. Okay, so capture will is going to store whatever the event that is happening outside the microcontroller, and match is going to perform some actions whenever a particular condition has been reached. Okay, now it does this match operation internally as well as externally. So internally, in the sense, it is going to take some action inside the microcontroller itself, and externally is nothing but it will take some action on the pins. Okay, like setting low on match, setting high on match, toggle on match, and do nothing on match. Okay, so we'll discuss about match as well as capture channels in depth when we come across those concepts. But for now, we'll talk about the basic timer and counter operation. Okay, we'll start with the applications of these timers. Now these timers are used for counting the events. As I told you that they can be used for as counters, and they can also be used as free running timer for delay generation. Now they can also be used for pulse width modulation. So we can also generate PWM waveforms with the help of these timers. Okay, so let us see each of these features. Now these are the capture and match pins which are provided for this microcontroller. As you can see, cap 0.0 or cap 1.0. Now here the first numeric, that is this cap 0 or cap 1, indicates they are related to timer 0 or timer 1, and the second numeric here indicates the channel number. So cap 0.0 here indicates timer 0's channel 0, cap 0.1 indicates timer 0's capture channel 1, and cap 0.2 indicates timer 0's capture channel 2, and cap 0.3 indicates timer 0's capture channel 3. Okay, now under each of these categories you can see multiple pins, or one of the pin would be acting as capture pins. Okay, so you have to select any one of these pins to work as capture pins. Okay, we'll discuss about those things. And when here you can see external match pins. Same thing here, the first numeric indicates whether it is timer 0 or timer 1, and the second numeric here indicates the channel number. So match 0.0, this is for timer 0's match channel 0, match channel 1, match channel 2, match channel 3. These are all for timer 0, and these are all for timer 1. Okay, as you can see, there are some pins which are under this category. So any one of these particular pins can be used as match pins. Okay, now these are the registers which we are going to see now. Okay, so if I want to use the peripheral, that is timers, okay, then I have to access all of these registers. So we'll discuss about each and every register, okay, according to the functionality as well as according to our requirement. Now the first register that we come across now here is TCR, which is nothing but timer control register. So as I always say that whenever we come across a peripheral inside the controller, then we can easily, or we can study about one particular register that we can guess easily, that is control register. So with the help of control register, we can give some configurations to the peripheral. Okay, so in the same way, with the help of this timer control register, we can give some configurations to the timer. Like as you can see here, it's an 8-bit register. Now out of these 8 bits, we'll be using only 2 bits. It means only 2 bits are used in case of LPC2148, and remaining 6 bits are reserved. Okay, so here the first bit, that is this particular bit 0, Now if this is programmed to 1, then the timer counter as well as the prescale counter are enabled. So it means the basic timer register as well as some prescale counter gets enabled. So if you want to use the peripheral timer, then you have to enable this. So it should be programmed with logic 1. And you have counter reset. Now we have one register like prescale counter, so it's only read only. So if you want to reset that prescale counter register, then definitely you have to program it to 1. So as you program this particular bit to 1, then prescale counter becomes 0 or initialize it to 0. Okay, so this is how you can reset the prescale counter, which is a read only register. Okay, and this is about timer control register. Now you have a count control register, which is nothing but CCR. Okay, now with the help of this register, you can select any one of the functionality of timer, that is whether you want to use it as a basic timer for delay generation or you want to use it for counting the events as counter. Okay, so as you can see, it's again a 8-bit register, out of which we will be using only 4 bits. The first 2 bits will specify whether you want to use this peripheral as timers or else as counters. Okay, so if these 2 bits are programmed to 0, then it means that you are using this timer peripheral as a timer. So it is in timer mode. So we can use now it for delay generation. And the remaining 3 combinations are reserved or else are used for counter mode of operation. So it means when you place this peripheral in any one of these modes, then they are going to count the external pulses. Okay, so counter mode, that is 0 1. So here TC is incremented on rising edges on the capture input. So what happens here is, now the TC, which is nothing but a register, that is timer counter register. This is the register which is going to hold the counting values. Now this register gets incremented by 1 for every rising edge on the external counter pin. Okay, and if it is 1 0, if you are programming it to 1 0, then what happens here is, now this TC gets incremented by 1 for every falling edge on the counter pin. Okay, and if it is 1 1, then it gets incremented, that is TC gets incremented by 1 for both the edges. Okay, for rising as well as for falling edge. Now what are these counter pins? Now if you are aware of 8051, there you have something like T0 and T1 pins. Okay, so if you are using the timer peripheral as counter, then the clock signal is given through the pins T0 and T1, so that the timer is going to be incremented, or it is going to count the number of clock pulses that you are giving through T0 and T1. So in the same way, now you can use these capture pins to act as counter pins. Okay, so it means when the peripheral is used in counter mode, then these capture pins now will work as counter pins. Okay, so when timer peripheral is used as counter, then these capture pins will be can be used as counter pins. So you can give the clock pulses through this capture pin, so that the timer counter, that is TC, gets incremented by 1. Okay, and that depends on the mode or else the combination which you are using. Okay, and as you can see here, count input select. So as you have 4 channels, out of 4 channels, which channel you want to select? Okay, so that is specified with the help of these 2 bits. If you are programming these 2 bits with 0 0, it means you are going with cap n.0. So here n indicates whether you are using timer 0 or timer 1. If you are using timer 0, then it becomes cap 0.0 channel. So inside cap 0.0, again you will find some pins. So any one of the pin can be used as counter pin. Okay, now if it is 0 1, it means you are going with cap n.1, where n again indicates are you using timer 0 or timer 1. So if it is timer 0, then it would be cap 0.1, that is timer 0's capture channel 1. If you are using timer 1, then it becomes cap 1.1, which is nothing but timer 1's capture channel 1. Okay, now in the same way for 1 0, that is n.2, and 1 1 for n.3. Okay, so under each and every channel category, as you have seen, there are many pins. Okay, there are many pins. For example, if you take cap 0.0, now under this you have P0.2, P0.22, and P0.30. Now out of these 3 pins, you can select any one of the pins to act as counter pin. Okay, so for making any one of the pin to act as counter pin, you have to configure the register, that is pin cell register. Because basically all these 4 pins will be acting as by default they will be acting as GPIOs. So if you want to use any one of these pins to act as a capture or counter pins, then you have to configure pin cell register. Okay. So the thing is clear with count control register, that is with the help of this you can select the mode of operation, as well as you can select any one of the capture channel which is going to be acting as counter channel or counter pins, right? Now you have three more registers like timer counter register, prescale register, and prescale count register. Now all these three registers are interrelated. Okay, we'll see how they are interrelated. Now for now, timer counter register, it's a 32-bit register which is going to hold the count value. Either it might be counting the external pulses, or else it might be counting the internal pulses. Okay, so as it is a 32-bit register, now the maximum value that it can hold is this 8S. Okay, and if one more clock is reached, that means if it counts one more clock, then it wrap backs to the this value. So it is nothing but rollover. This condition is nothing but rollover. Okay, and prescale register. Now this register will specify the maximum value of this prescale count register. We'll see. Okay, and then prescale count register. Now this is the register will get incremented by 1 for every clock pulse that it receives. Okay, so what for the clock pulses received by timer peripheral, now this particular register gets incremented by 1. For every clock pulse when the timer peripheral receives, then this particular register gets incremented by 1. Okay, let us see with an example. Now from the above definitions, I have made some points here, like TC gets incremented by 1 for every PR plus 1 cycles. Okay, now what happens here is, now this TC value will be incremented by 1 for every PR plus 1 cycles. We'll see what it means. Okay, and PR register specifies the maximum value of PC. Now this particular PR register will specify the maximum value of this TC register. Okay, and then PC will be incremented for every single clock cycle until it reaches PR, then it will be reset. Now this PC will increment for every clock pulse that the timer peripheral is receiving, and it gets incremented, or it will be incremented until it reaches the PR value, that is the maximum value which is already specified. Okay, and as soon as this PC reaches PR, then PC will be reset or initialized to 0, and then PC gets incremented by 1. Okay, we'll see that with an example. See, before the first clock pulse, now the TC value is 0 and PR value is 0. Now this has to be initialized by the user. Okay, and PC is read only, as I told you that. Now PC will start from the default value, that is 0. Now after the first clock pulse, what is happening? So PR is mentioning the maximum value of PC. That means now 0 is the maximum value of PC. So what is happening here? PC will be incremented for every single clock cycle until it reaches PR. So already this PC has reached PR. Okay, now what happens? Then it will be reset. Okay, and PC gets incremented by 1 for every PR plus 1 cycle. Now PR is 0, so PR plus 1 is nothing but 0 plus 1, which is nothing but for every 1 cycle PC gets incremented by 1. We'll see that. So after the first clock pulse, what is happening here? Now TC has become 1. Why? Because PR plus 1 here is nothing but 0 plus 1. So 1 cycle has been reached, or 1 cycle is received. So TC gets got incremented by 1, and PC value, as you can see, now it is holding 1 and immediately becomes 0. Why? Because it gets incremented until it reaches PR, then it will be reset. So this is how TC, PR and PC are interrelated. Okay, so PC will be incremented for every single clock pulse that the timer peripheral is receiving, and PR will specify the maximum value of PC. Okay, so PC gets incremented until it reaches PR, and then initialize it to 0, and then PC gets incremented for every PR plus 1 cycles. So this is how all these three registers are interrelated. Okay. Now let us see the next concept, that is match types. Now here match concept. So it is of two types, internal match and external match. As you can see, action is performed internally inside the microcontroller, then it is nothing but internal match. If you are performing the action externally on the pins, then it is nothing but your external match. So it has totally 4 channels: channel 0, channel 1, channel 2 and channel 3. Okay, and every channel is provided with a register, that is match register. We call it as match register. So MR0, MR1, MR2, and MR3, these are the registers for channels, the channel 0 to channel 3 respectively. Okay, now all these four registers are 32-bit registers. Now what is happening? How match is performed? Let us see that. So when actually the match is performed, always TC is compared with MR0 to MR3 registers. So always the timer counter register, just now we have seen, which is going to hold the count value. Now that particular register is always compared with these match registers, which are inside channel 0, channel 1, channel 2, and channel 3. Okay, so if any match is generated, it means if TC equals any one of these match registers, then a particular action can be performed. So we can take a particular action, or we can perform a particular action whenever this TC is identical to any one of these match registers. Okay, and that action can be selected or specified by using one register, that is MCR register, match control register. Okay, so TC is always compared with MR0 to MR3 registers, and if any match occurs, it means if TC value is similar or identical to any one of these match register values, then we can perform a particular action. Now that particular action is specified or selected by using match control register. Okay, let us see that how to do. So this is the match control register. Now here it is a 16-bit register, and out of these 16 bits we'll be using only 12 bits. Okay, so 3 bits for a single channel. So there are totally 4 channels. So 4 into 3, which is nothing but 12 bits. So we'll be using a complete 12 bits out of 16 bits inside this match control register. Okay, every channel is occupying 3 bits. Let us see what it does. Now 0, 1, 2, these are the 3 bits which are used by channel 0. Now if you are programming this particular bit to logic 1, then what happens here is, whenever the TC value equals MR0, then it will generate an interrupt. Okay, so whenever TC value equals MR0 register, which is under channel 0, then it will generate an interrupt. Okay, if you disable this, then interrupt is disabled. Okay, now if you are enabling this particular bit, okay, writing a logic 1 to this particular bit is nothing but enabling it. Okay, now whenever TC value becomes equal to this MR0, then it will reset the TC. Okay, so TC is the register which is holding the count value. Now that gets reset. It means it will be initialized to 0 again. It starts from 0 counting. Okay, now the third bit here is MR0S. Okay, which is nothing but it will stop TC as well as PC when MR0 equals TC value. Okay, so here you can take 3 actions for a single channel. Okay, that is, if MR0, if this particular bit is programmed to 1, then what happens? When MR0 becomes equal to TC, you can generate an interrupt. Okay, when MR0 becomes equal to TC, if this particular bit is programmed to 1, then TC gets reset. Okay, or else you can also stop TC as well as PC. Okay, now in the same way, these 3 bits are used for channel 1, these 3 bits are used for channel 2, and these are 3 bits which are used for channel 3. Okay, if MR1 equals TC, then you can perform these possible 3 actions, that is generating an interrupt, or resetting the TC, or else stopping TC as well as PC. Okay, so this is how you can take internal actions. Okay, so this is nothing but internal match concept. So you can generate the match internally, or you can perform some action whenever a match occurs, that is internally inside the controller. Okay, now let us see one more feature, that is capture channels. Now here again it is provided with 4 channels: channel 0, channel 1, channel 2, and channel 3, and every channel has its own register, that is CR0, which is nothing but capture register. Capture register 0, 1, 2, and 3. Now all these 4 registers are 32-bit registers. Now what do you mean by capture? Capture is nothing but storing something. Okay, so whenever externally if some event occurs, or some event is generated outside the microcontroller, then it will capture that particular event. Okay, so here for any external event on capture pins, TC register is stored in respective capture channel register. So it will capture the event whenever some event is performed on the capture pins. Okay, so capturing the event is nothing but storing this TC value. Okay, so for any external event on TC pins, now this capture feature is going to store the value of TC into any one of these channel registers or capture channel registers. Okay, now let us see what is see, as I told you that CR registers, that is capture channel registers, they will store the value for any event outside the pins or on the capture pins. But what is that event? Okay, now that particular event is again selected by one more register, that is capture control register. So we can select what kind of event, what kind of signal is going to generate an event which will store the value of TC into capture channel registers. Okay, so here it's again a 12-bit, 16-bit register, out of which we'll be using only 12 bits. Why? Because you have 4 channels, and each and every channel is using 3 bits. Okay, so these are the 3 possible events or 3 possible things that you can specify with capture. That is rising edge, cap 0, that is nothing but capture channel 0. Okay, rising edge. So for every rising edge on channel 0, okay, is going to capture the value of TC into CR0. Okay, that is done only when you are programming this to 1. So if you are programming this particular bit to logic 1, then for every falling edge on channel 0 pins will store or will capture the value of TC into CR registers. Okay, and then if you are programming it to 1, then it will generate an interrupt whenever a capture is generated. Okay, so this is how you can use this capture control register. Now these are the 3 bits for channel 1. Okay, as you can see, rising edge on channel 1 pins is going to store or is going to capture the contents of TC. It means the contents of TC are captured and stored inside CR1. In the same way, for every falling edge, it will store the contents of TC into CR1. And it will also generate, if you are programming it to 1, then it will generate an interrupt when a capture is generated. That means during the rising edge or during the falling edge. Okay, if you are programming these 2 or these 3 bits to logic 1, then what happens? It will capture the value of TC when a rising edge is appeared on the pin, as well as when a falling edge is appeared on the pin, and it will generate an interrupt for both the events. Okay, so this is how you can use the capture channel. Now let us see the last concept, that is external match. Okay, so external match, as you can see, these are the external match pins. Totally you have 4 match channels under timer 0 as well as under timer 1. Okay, so out of these pins you can only use one particular pin under each and every channel. Okay, for example, if I'm using match 0, which means timer 0, okay, and timer 0's match channel 0, then I can use any one of these pins to act as match pins, either P0.3 or else P0.22. Okay, now what is this external match? Let us see. Whenever TC equals any of match register, as we have seen inside in the internal matches, that TC is always compared with match channel registers. So whenever TC is identical to any one of the match register, then we can perform a certain action on the external match pins. Okay, so always TC is compared with match registers, and whenever both are equal, then we can perform a particular action on any one of these pins, match pins. Okay, now here what kind of action that we can perform on these match pins? Now that is decided by EMR register, external match register. So with the help of this, we can select a particular action to be performed on these pins when TC equals match registers. Okay, let us see what kind of actions that we can perform. Okay, see, external match register. Now inside this, EM0, EM1, EM2 and EM3. Okay, now these are the 4 bits which are going to represent the status of external match channels. They'll just represent the status of the external match channels. EM0 represents the status of match channel 0, 1 represents the status of match channel 1, 2 represents the status of match channel 2, and 3 represents the status of match channel 3. So status here is nothing but what is the current value that these pins are holding. Okay, and you have 8 more bits here, like EMC0, EMC1, EMC2, EMC3. where each and every channel is again using here 2 bits. Now we have to initialize, or we have to program these bits. Okay, for example, if I'm using EMC0, okay, EMC0 is nothing but channel 0. If I'm using channel 0, then I have to select a particular action by using these 2 bits. So if you have 2 bits, it means you can go with 4 combinations. Now what are those 4 combinations? We'll see that. So if you're programming those 2 bits with 0 0, it means you're doing nothing on a match between TC and MR. Okay, if you're programming those 2 bits with 0 1, it means you're clearing the corresponding external match pin. So you can clear the external match pin. Okay, that is when TC equals match register. Then if you're programming these 2 bits with 0 1, then you can clear the external match pin. It means a logic low is provided on that particular pin. If you're programming these 2 bits to 1 0, then whenever a match occurs between TC and MR, then it will send a logic high on the external match pin. And if you're programming it to 1 1, then whenever a match occurs between TC and MR, then it will toggle. It means if the earlier value on the pin is 0, then it will provide logic high. If the earlier value on the pin is high, then it will provide a logic low. So this is how we can use external match for generating the PWMs. Okay. So when you're using the basic timers, then you have to use the registers like TC, PC, TR, and CCR. Okay. So if you are using the capture, then you have to use CCR register along with CR0 to CR3. And if you are using match, then you have to use MCR in case of internal match, and in case of external match, you have to use EMR register along with match registers, that is MR0 to MR3. Thank you.